Hello everyone and welcome to Handmade here, the show where we code a complete game live on stream. Yesterday we sort of did some pondering regarding lighting. And where we ended yesterday's stream was kind of at the point where we were like, well, there really isn't any obvious solution here. I mean, that's sort of where we were at, and that's not surprising. That's just how lighting is. Lighting is one of those things that's just still prohibitively expensive to implement in some kind of first principles way where you're just really simulating light, the way light really works or something like that. And so the approximations are always pretty drastic, and it's very hard to know what the most economical approach is for any particular situation, especially since I'm not a rendering person. I don't spend all my time working on rendering, and there are plenty of people who do exactly that in the game industry. There's people whose entire job it has been for many years to just think about rendering. And when you're talking about just thinking about rendering, usually you are just thinking about light most of the time, right? That's a lot of what rendering is. It's light, how it behaves off surfaces, how it behaves in camera lenses, how it behaves in participating media, that sort of stuff. And so, someone who was more of a day-to-day render programmer than I am probably has some stronger opinions about these things. Doesn't mean they're necessarily right in some abstract sense, but it does mean that they usually have, here's how I like to solve these problems. So they would probably look at our game and they would probably say, here's how I want to approach this, because they've already done lots of experimentation in lots of circumstances and they know what they like, right? Other render people might have a different take, right? But again, they would still know what they like. So I think that there is a pretty reasonable chance that a more experienced render programmer kind of person would have a direction they really wanted to go. But I don't, because I don't spend my time doing rendering programming very often. It's one of the smaller parts of what I tend to do on a day-to-day basis. And so I don't have a overwhelmingly strong bias towards implementing the lighting in one way or another. As a result, sort of where I ended yesterday's stream was saying, well, I don't know. I mean, here's some ways we could do it. I'm like, I don't have any particular opinion about it. And where I sort of ended up was like, well, let's try something that's light probe-esque, right? That's sort of where I ended up. So the thing with doing light probes is basically how light probing works is you have points in your scene that are defined as light probe points. Those light probe points are hints to the renderer about where it should spend its time trying to find lighting solutions, and then anything that wants to get lit typically uses the light probes to interpolate the lighting between them, right? So that's basically what we're looking at. Now, I wanted to sort of point something out here that's a little confusing, but I'll just start by doing it. Let me also mention today is 492. So if you want to follow along at home, you want to use day 492, that's good, 392. You want to use day 391's source code because that's what I've got here that I'm starting with. So if we take a look here, ooh, that Visual Studio started up much quicker. Maybe uninstalling that, uh-oh. I don't even know. So it's amusing. Literally, you folks who are watching this in the YouTube won't have known this, but literally moments ago in the pre-stream, I was talking about how commercial software is unusable these days. Because licensing makes it impossible to maintain a sane development environment because things are always breaking, and they usually break because the licensing doesn't work. Well, as if on cue, here we are with our Visual Studio Community 2013 edition, right? which I'm only using. Normally I use Visual Studio 2012 because that's what I have a commercial license for. But I was using Visual Studio Community 2013 edition because when we started this project, I wanted to use something that people could access who don't have a lot of money, so we picked the version of that. But even though it's a freely available product, Microsoft, of course, has decided that it will break every once in a while, right? Now, who knows why they decided to break? Maybe they thought it was just a good idea to make people renew their licenses because you got to check in with Uncle Bill to make sure that, you know, he's okay with you using the software. Or maybe this is just a bug because, hey, everything else in Visual Studio has bugs in it, so of course the licensing the licensing software probably would too, right? But either way, this is exactly the sort of thing that now happens with pretty much all commercial software projects. It's happened to me with my commercial license of Visual Studio 2012 that I actually use for work at work, right? And this is unacceptable. I don't know why we think this is acceptable, right? I don't think anyone would be okay with this in other realms, but software is like grooming people to be okay with it. If you went down to try and start your car in the morning and it said that you couldn't drive to work because you hadn't checked with Ford to see if you still owned the car, I'm pretty sure people would be furious about that, right? If you went to your refrigerator and opened it up and you found that all of your food had rotted because the refrigerator said that it could not verify with Frigidaire that you still owned the refrigerator, these would be ridiculous things, right? I don't feel like anyone would be okay with that. I feel like that company would probably go out of business. Yet somehow, and I don't know how, people think this is an acceptable way to ship software. And again, not just free software like Visual Studio Community 2013, but actual commercial software, because the commercial version of Visual Studio does exactly the same thing. Trust me, I have it and it does. So basically what it is you're paying people to create problems for you, which is absolutely ridiculous, right? It should not be something that people put up with, and I don't know why they do. So I don't know. There's two things we can do here. One thing we can do is we can, we can take this machine and say, all right, let's check for an updated license and try to get Microsoft to agree to license this thing to us. That ostensibly has been, you can go on my stream and watch me having used it for 2 years, and apparently that's not sufficient to verify that it actually was something that I should be using. But oh well. Or we can decide just never to use this piece of software again, which honestly at this point I'm a little bit more inclined to do. So, the other option we have is install Linux on this machine and just get rid of the Microsoft software entirely, which honestly at this point seems like a pretty good idea. The other thing we could do is try to switch to something like Clang and get rid of Visual Studio on the sort of Windows side of things while still using Windows. I don't know which of those is a particularly good idea. Obviously, we have some issues, the same issues that everyone else has, and the only reason that I assume people ever are still on Windows anyway, which is that you sort of have a vested platform buy-in where various pieces of software that you use are only available on particular platforms. So, for example, we need to be able to use Fourier for our editing, and we need to be able to use OBS for our video streaming, and we need to be able to use Milton for our Blackboard, right? That's what we tend to use. Now, of those pieces of software, I'm pretty sure that Fourier has a Linux version. I don't know if Milton does, so let's check. So somewhere around here, there's a downloads, right? Download. And so let's see what it's got. Where's the GitHub? There it is. Yeah, so I'm pretty sure. This is Windows only. Now, I don't think it would take a lot to port it, right? Here's the source code. Here's the source code, and you can kind of see that there's even a little bit of Linux suggestion here, right? Like the platform, Windows, Unix, Mac, SDL, right? So I don't know to what extent this is supported or going to be supported on other platforms. It's a good question. We should ask Sergio about that. Yeah, you can see here there's Linux and OS exporters tended for the future. But here's how you do the build, for example. And so, it's not out of the question that we could get to a point where we could use this for drawing on Linux, right? So that's good, right? We have the source, so if we had to port it ourselves, hey Sergio, if we had to port it ourselves, we could probably do something like that as well, right? So those are really the only two things we need, because I'm pretty sure OBS already works on Linux, right? OBS Studio, which is the latest version, is Linux compliant. So I think that would not be a particular problem either. So I guess what I would say there is, what do we want to do? It's a really tough question, right? It's a really tough question. I feel like we should take a poll about what we should do here. Do we want to try to get Visual Studio working? Or do we want to switch to Linux? I feel like there's a lot of cost to switching to Linux, right? We won't have a particularly good debugger anymore, because there really aren't any debuggers for Linux that are any good. So it'd be pretty rough if we did that. We could try to use Clang on here, but then of course we have the same problem. We wouldn't have a really a useful debugger, right? So it'd be pretty tough, if that makes sense. So yeah, I don't know. I guess what we can do is we can try to see. I don't know what this is really asking me for here. The only reason I would have one of these is for when we authorize this initially. So I can look up the password for it, I guess, because I would have saved it, and then try to get it to work. So maybe we'll do this. This seems fair. I will try putting in my account credentials here. And if it works, we will keep using Windows. If it doesn't work, then we switch to Linux. That's, I think, the fair option, right? If they don't want me to use their software, they don't want me to use their software, right? Microsoft makes it abundantly clear almost every day that they don't want me to use their software. And this is a pretty blatant example of that. So we'll give them one more chance, and if it doesn't work, then we move on. Hold on. All right, I have gotten my personal laptop out, And I am looking up to see what we've got. All right, so I don't really know if this is accurate here. Whoa. Okay, did that. I think that worked. All right, here we go. We're going to enter our password here. And everyone will now know how many letters there are in my password. Or numbers, I guess. But that's fine, because honestly, if somehow you decided to brute force my Microsoft password, this is the only thing on my Microsoft password. So all you would really have is a non-working version of Visual Studio. No. Is this a joke? I mean, really? Are you actually showing that? Who writes this stuff? Did that work? I have no idea if it worked. It looks like we're able to launch Visual Studio now. All right. Thankfully, I happened to save that password. Microsoft is saved for the time being. I have no idea what that dialog box was asking me. All right. Well, that was fantastic. So productive. All right. I was trying to, if I can even remember what was going on here. Oh, good, and it forgot which project we normally have loaded. Apparently, because it was like, I gotta load my license file. That's the important part. Not what you were working on, Casey. You're working on stuff that is irrelevant to me. So what I wanted to talk about was the fact that, if you recall, we are a fake 3D renderer in a lot of ways because we have to work with sprites, which aren't actually 3D. So we have to kind of do some shenanigans to make that work properly. And what you can see here is that when you are working in the normal view that we expect, that's fine, because hey, that's the angle the sprites are drawn to look like, so everything's good. But if we look at other camera angles, like you can see here, we end up in a situation where the individual sort of sprites wouldn't really be looking like they look if you were looking from this angle, right? And that's fine because we never look from down here, but obviously when we're talking about doing stuff like rendering light probes or something, if these things were going to occlude light, they need to be standing up straighter, right? They need to be standing like upright. So we have a fundamental disconnect, again, with our 2.5D-ness, or whatever you want to call this, 3D with sprites, I don't know what. But the fact that we do our rendering in sort of this way to support sprites, which we need to because that's how the art goes, we have a problem of trying to figure out exactly what we're going to do as far as doing like light occlusion and stuff like that, because we probably can't render things in this way, because if you were looking like this, you'd see nothing along the horizon, but you should see a big wall of trees blocking you, right, as far as lighting is concerned. So it sort of strikes me as being the case where when we render when we render the world for lighting, we almost need to do it in a sort of different way than when we render the world for visuals, right? So this kind of got me thinking, you know, or I should say gets me thinking. I haven't really thought it through yet. But this makes me kind of think a little bit harder about how we might want to treat the lighting versus how we treat everything else. And so what I wonder is, I do wonder if maybe what we need to do is something more like a voxelization pass or something like this on the game that's really more about splatting sort of vague colors in rather than trying to render actual stuff. And the reason that I'm thinking about that is just because since our game is not at all geometrically accurate in 3D, I'm not sure we can really do something like rendering light probes in a traditional sense, in the way you normally would, because I'm afraid that they won't really capture anything that we need them to capture, right? So what I'm wondering is if we need to do something more like splatting colors into a texture that we then kind of just blur out and use for the lighting, or, you know, something like this. And I'm not really sure. I don't know what we want to do in that regard. So I still think we don't quite have what we need to know in order to really produce reasonable lighting. But given all that, I guess what I would say is I think we might want to skew more towards the taking a sort of pseudo 3D texture approach, screen space 3D texture sort of a thing, and then sampling that, and that seems like maybe a little bit more of an approach we could take, right? So let's talk a little bit about that, and then maybe what I was thinking I might do is try using a 3D texture to do non-directional lighting so that we could get that working, and then figure out how to sort of bootstrap that into something that worked for directional lighting, right? So what do I mean here? So let's imagine that we just wanted to do the exact same lighting that we're doing now, but we wanted to look it up in a texture, right? So what are we doing right now? Well, right now what we do is we say, all right, here's the world. We know that there is a point light source in it. We gave it a particular fall off, right, that it has in the world. And so from there, we just know, okay, if there's a thing here, we compute the lighting based on its distance from this thing, and off we go, right? But it's always a point, right? It's a vector that's like a position of the light and a strength of the light, I think, are the two things we did. So how bright it is and where it is. So if we wanted to do this instead in a texture, you can imagine doing sort of a reverse process, right? If we wanted to make a texture for this, what we could do is say, well, all right, let's suppose that something was here. What it could do is just sample from the texture what its lighting is. And then what we would do is we'd say, go the opposite direction. If I've got a light that's in here, I render the light into the texture as a big blob, and then I'm done, right? And then when I come in and I look it up, I get what the lighting should be at those points, right? Pretty straightforward. So allergied. There's lots of construction in Seattle, and I feel like it kicks up. This is my like crackpot theory. I feel like there's so much debris in the air that I'm always sneezy about it. It's probably not true. It's probably just plants. Anyway, so doing this is not particularly difficult to conceptualize, right? It's just that these two processes are sort of like reversed from each other. In one, you just take the light source and you store just the like 2 pieces of information necessary to reconstruct it, and then every time you want to shade a pixel, you just use these 2 and the lighting equations to reconstruct what the light is at this point. The same thing happens here in reverse. We take those 2 things and we rasterize them out into the whole texture, then we sample from it, right? And you can see why this is something that I'm interested in doing. It's because this allows me to start getting a lot more information into the lighting. If I wanted thousands of lights in here, I would have to every pixel compute the lighting equation for thousands of lights, and that's not going to fly. On the other hand, if I do this, forward rasterizing 1,000 lights into this texture is relatively cheap, and when I then go to look up a pixel, it's just a constant lookup time to just fetch out what the lighting ended up being there. Right? Now it has some downsides, which is that that texture obviously only has a certain limited resolution, and the higher resolution it is, the more expensive it will be, and blah, 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 right? So there's definitely costs to it. It's not free. And there's all sorts of ways we might encode it and things like that. But it's, reasonable. So you might imagine taking this and extending this to 3 dimensions as well. If we took the view frustum, for example, and we said, all right, let's take the area we're viewing. Here's the far clip plane. Here's the near clip plane, which are whatever we want them to be. And let's divide this up into cells. Now that's a 3D texture, right? Because again, this is a frustum, so it's actually this sort of thing. Right? So you can imagine us taking a essentially voxelized version of the view and just creating out of that our lighting, right? And so that seems pretty reasonable to me, right? The only thing that's kind of tricky about it is, again, figuring out then, I guess what I'd say is the resolution might be an issue, hard to say. The cost of rasterization, cost of lookup, those sorts of things. But the biggest problem that we will have here is when we want to simulate the directionality of the lighting, right? So the problem that we get is lighting intensity and color can sum together. So I can splat as many lights as I want in here. And in the places where they overlap, like in here, I can just sum up the R, G, and B intensities and get a perfect representation of the brightness of those lights at that point, right? No problem. What I can't record is what direction the light is coming from, right? Because each one of those lights was coming from a different direction. So when I sum up the intensities, that's accurate. If I were to sum up the direction, I'd get the average direction the light was coming from, but the average direction the light was coming from doesn't really mean anything, right? So the surface response is going to be completely wrong if I've got 3 lights, let's say, and I only keep one direction, which of course, as we all know, is the best band, one direction. And so what we're really talking about is keeping the band one direction at every texel here. But in addition to keeping the band one direction, we also have to compute the lighting equation, and unfortunately, one of the things that a lot of people don't know about the band one direction is they don't actually know very much about physics. So unfortunately, when we go to use that one direction to figure out what the lighting is, we will not get a very good result, right? And to make this more explicit, you can imagine this yourself. Here is a cube looking top down. these two faces obviously point in opposite directions. Here is a set of lights that are overlapping the cube. Here is a red light. Here is a green light. I would expect when I compute the lighting for this face to be almost entirely green. I would expect that this face should be almost entirely red, right? But if all I store is the intensities here, they will both be sort of greenish red, right? Because what will end up happening is I don't have any way of storing which direction each of those colors came from. So that's the problem, right? That's the problem you end up getting. So what do we do about this? Well, probably what we want to do about this is take some sort of a hybrid approach, right? What we want to be able to do here is store something into our texture that allows us to reconstruct the directionality of the lighting a little, right? That gives us some ability to do something with the directionality of the light if possible, right? And so what a lot of people tend to do with stuff like this is they'll use, for example, encodings. So you may have heard of like spherical harmonics. Spherical harmonics is one way of encoding a mush of lighting in a way that keeps the light values in a way you can reconstruct some directionality from them. And you can think of this as being very analogous to like the Fourier transform for audio, for example, where you're taking this complicated signal, right, this sort of like, you know, here's my audio signal, and turning it into a series of like a graphic equalizer version of like various sine wave frequencies, right? So spherical harmonics is exactly the same sort of thing. Spherical harmonics says, let's go ahead and store some directionality to the sphere, right? The incoming sphere of information. Let's store like the primary lobes of that incoming incident light, right? And it's, again, in order to really reconstruct the lighting in its entirety, you need to store lots of coefficients on the sphere. And I can try to show you those if there's a good diagram here on them. Spherical harmonic coefficients. Oops, I didn't want that. Here you go. So this is a tree of lobes, and these are sort of intensity lobes, you can imagine, of the intensity of this function in the direction that it goes, right? And so you can see as they start getting more detailed, it gets more and more lobes. This is because, like I said, spherical harmonics are very analogous to something like a Fourier transform. And for those of you who don't know what a Fourier transform is, a Fourier transform is something that converts a amplitude-based signal. So like I said, something that's like audio, like an amplitude, it just kind of like fluctuates, into something that's a sum of a series of transcendental functions. So a sum of a series of sine waves. So for example, and what this is a pretty interesting aspect just of signal processing theory, is that any signal can be approximated and eventually matched exactly by a series of sine waves to a certain degree, right? So what you end up with is you end up with sort of a series of sine waves at doubled frequencies, right? This is a really bad drawing. You know what? This is not going to work. Let's try it this way. So what you get with something like a Fourier transform is you essentially get these various coefficients of which kinds of frequencies are present in the signal and at what strength. Right? And so what you get is like, coefficients going down in terms of their effect. You get these sorts of sine wave decompositions of the signal. So, if I had a signal that kind of looked like this, right, you would say, well, obviously it's got a very strong first coefficient here that sort of matches that. And then it's got a little bit of this signal in it here for that wobble, right? And you keep summing these together to get eventually back to the actual signal that you had, right? Now, the idea behind this, and why people tend to want to use things like Fourier transforms or like the discrete cosine transform, which is a similar version of it, of the same process for graphics, is that you want to be able to throw out the higher frequency stuff because usually humans are less sensitive to it. So for example, if I want to approximate this, if I want to approximate with something like that, the Fourier transform becomes very useful because you can just keep the bottom part and throw away these top parts when you're trying to kind of compress that signal down to smaller space, right? So spherical harmonics are the same way. And much like sine waves, they have like a positive and a negative weighted lobes, right? And I don't know which one they're trying to show here. Like probably blue is positive and green is negative. I don't know. It doesn't matter. But point being, they add in one place while they subtract in another, right? So at the top, you just have an overall color of the function, an overall bright strength of the function. And then the next down, you get the three primary axes, right? X, Y, and Z, have lobes on them that say how strong the function is in those directions, and it subtracts from the other direction. So it adds to one direction and subtracts to the other. Then you get other shapes as you get down to the lower coefficients and so on and so forth, right? And again, the idea behind these functions is, hey, let's suppose for a given channel, like the red channel, I'm willing to store 4 numbers. Well, I could store the 4 coefficients of these things and sort of have some directionality understanding to my lighting, right? Anyway, the point of this stream is not to teach you spherical harmonics because, hey, I don't even really work with spherical harmonics, so I'm the wrong one to teach you anything about spherical harmonics. It's more to just kind of mention, as we go here, that what we need in this case, what we would need to do if we want to recover directionality from the lighting, is we need to store something in our texture map that helps us reconstruct something we can use for the direction of the light, right? Okay. So let's talk a little bit about what that might look like, and we can play around with it, right? It'll be an experimental process of once we have things working, we can kind of play around with what we store there and see how it does. But anyway, so remember, if you recall, what we want to do, right, is we want to produce a lighting equation for our surfaces. And remember, we started to talk about this. Lighting equations are things which want to be able to compute for a specific eye direction. Here's my eye, right? For a specific way that we're looking at the surface, we want to take the inbound light that we know is hitting this surface and produce some kind of R, G, and B intensity that goes out along this ray so that the eye can know what it is. That's what we want, right? And in order to produce that, we actually have sort of 2 distinct categories of lighting that are going to happen here, right? We have highly reflective elements of our lighting and highly diffuse elements of our lighting, right? We can kind of separate those into those 2 broad categories. Remember, a mirror is something that reflects something directly and that behaves kind of like the sort of faux specular thing that I've got in here right now, right? Remember we played with this? That's a very reflective surface. It's a surface that narrowly reflects the light incoming on it, right? And you remember we kind of played around with this in a limited sense. But we can change it over, even with the limited thing we have right now, we can change it over by playing with these coefficients. We have a 2.0 specular coefficient, but a 1.0 diffuse coefficient. We could instead turn off that specular and just use the diffuse. And what we would get is something that, again, is more like a highly diffuse surface, right? A surface that just scatters light in all directions. And then when we have a light on here, right, we get something that just more kind of flows out around, doesn't really reflect. And when I move my camera around, right, I don't get a lot of change in how the light responds because, again, it's diffuse, it's radiating in all directions, so it doesn't respond that much to how I'm looking at it, what angle I'm looking at it. Okay? So again, we have two broad categories of light there, and what that means is that when we're sort of developing our approximate light equation, even though real lighting requires us to take every four-dimensional pair into account, every light direction has to then take into account every possible two-dimensional angle set and sum all of those lights with different weights, all of those incident lights, you know, that's not what we're doing, right? That's a ray tracer's job. We're doing approximate lighting. So we really have two things we want to consider. We want to consider those two categories, the specular and the diffuse, right? And so what we want to do is we want to come up with some kind of a lighting lookup that allows us to approximate both of these if we can. And obviously, again, this is a highly approximate process, so we're not really going to get great results out of either, but we just want something that looks pleasant, right? This is a game with cartoon art style. We're not trying to be photorealistic here, so we don't have to sweat it too bad. So how would we do this? Well, if you think about what we've got here, what we want to do is have something that can produce a directional light for specular and a non-directional light for diffuse, right? But non-directional is kind of in quotes here because even though it's sort of non-directional, it still has a directional mask on it. So remember, we've got the cosine theta law here, which tells us that as the angle gets steeper, as the light comes in, it reflects less of the light out, proportional to the cosine of the angle. So we will still want things coming from this direction to contribute more heavily, potentially, to the result than things coming from this direction. So it's non-directional in the sense that we would like to know all of the incident light that's coming in, but it is still somewhat directional in the sense that the direction at which the light is coming in might get attenuated. On the other hand, the specular doesn't want to know all that. The specular just wants to know, for the reflection angle of this surface, whichever it is, I just want to know the color in that direction, right? And I don't want to know the colors in I don't want these other colors to contribute, right? So what we want here is something that can reproduce those angular queries, basically. We want something that given a normal, well, I shouldn't say normal, given a reflection vector. So the eye comes in and we give it this vector here, right? And then given a normal, which is this vector here. So given a normal, we want something that will reproduce the diffuse lighting. And given a reflector, this here, like R, and giving a reflector, we want something that will give us an approximation to the specular. So that's really what we're looking for in terms of our lighting. Now, if we did an incredibly amazing, wonderful, superb job at doing this somehow, the specular would be able to be cranked all the way to a perfect reflector that has no glossiness whatsoever, and you could do like mirrored surfaces, right? Like mirrors and stuff like this. We're not even going to attempt that for this project. And the reason that we're not going to attempt that, in addition to requiring like a lot of work on the rendering side of things, is because we can't actually do that since we don't even have the ability to render what our art looks like from other directions. And once you start talking about reflectors, you have to know that, right? So we actually don't want mirrors in this game because we don't have the ability to really render stuff in mirrors. So for example, let's suppose that the hero is standing on a mirror. When I look down here, I should look up and see what's under his chin, right? That art doesn't even exist. So the only thing we could really even attempt with things like real, true specular reflectors are fake reflections, ones that are the kind that people complain about. See if we can get a good one here. There you go. So that's kind of a good example of the kind of thing we would have to do, right? If you take a look at that image, you can see that all they really did was mirror the thing that they were looking at, and literally mirror it in Photoshop, and then draw that reflection. But that is not at all what a reflection actually does, right? A reflection does not work that way at all, right? It is not that kind of an image. Trying to see that looks a little bit better. Let me see if we can get a good one here. Well, that's an obviously very bad reflection. It illustrates the problem very well. Here we go. I think that's a really good one. Okay. But anyway, yeah. Apropos of nothing, there's a limit to what we can do with specular reflections, because reflections aren't mirrored versions of the same thing you see when you look at the mirror. The only time that would be true is if you couldn't see the mirror. So if I was looking at a mirror directly head on and I had a sphere above it, that sphere would be reflected exactly perhaps through the mirror in a sense. Shape-wise, sure, right? But I can't see the mirror. Once I can see the mirror, then whatever's on it, I'm actually seeing the underside of that thing, right? I'm seeing the top when I look down here, but I'm seeing the underside when I look through the mirror. Because the mirror bounces the light. It doesn't reflect the light that I'm looking at. It reflects the light that hit it, right? And so it's a very different thing. So I'm not really even going to try for those in Handmade Hero. We could try to go through, jump through a bunch of hoops to get them to work in a fake way. Like I said, I don't really want to do that. I think it's just better to say we're not going for reflection effects here. Yes, they're cool. By all means, if you like them, try to do them. And you can come up with fake ways to try and do them with sprites, but I don't really want to go down that route. So really more what I'm looking for is a general glossiness, right? Something more like a surface that kind of reflects color a little bit in a directional sense. More like maybe a varnished floor does, but does not try to really reproduce the image so that you can't really see a clear image in it that is 100% pixel identifiable, right? We want something blurry. But I would like that, right? If we can get a nice blurry reflection, a nice glossy reflection in there, it adds a lot of character to the scene, because as things move through the scene and you kind of get this nice sort of glossy quality to them, it adds some variety to the material instead of being kind of dull and chalky. So we would like to get some of that if we can. Right? So what we want to produce is some kind of function where we can pass a normal and get a diffuse, and pass a reflector and get a specular. right? And honestly, like I said, I don't have a preconceived notion about how to do this, but if we were talking about storing this in a texture, right, then what I would imagine is, let's suppose we store 3 textures, an R, a G, and a B texture, and each one of these can be like 4 channels, right? So we can have, let's say, 4 8-bit channels or something, or maybe if we're feeling really gung-ho, 4 floating point channels. I don't know if we've got that kind of bandwidth to spare. But that's what we've got, right? We've got the ability to store these things into channels here, and we can store 1 for red, green, and blue, right? So rather than just the intensity of those colors, which we know we can store, so we know we can use 1 channel to store the intensity, and that will be exact if we wanted to. Let's say, what if we give ourselves 4 channels? Could we store something more than just the intensity? Yeah. And it's hard to say. But for example, one thing we could do is encode, let's say, the cube without the bottom face or something. Right? So instead of something like spherical harmonics, maybe, you know, we could do something like encode these faces of the cube. Like, or you know what, we could even just encode something like this. Since we're looking top down, we could encode how much light was outgoing in each of the 4 directions. Right? What's the red outgoing intensity in each of the 4 directions? I know it sounds ridiculous. It's incredibly lossy, but we could do it, right? And furthermore, if we wanted to spend even more resources on it, we could get even more accurate, right? Another thing we could do is say we have 6 textures, 1 for each face of the cube, and we've got 3 channels per texture, R, G, and B. Leading to a 6 times 3 storage requirement, right? And I don't know, again, that could be in 16-bit, or it could be, you know, so maybe it's by 2. So we end up with something that is 6 times 3 times 2. That's 36 bytes. And who knows, maybe it's 512 by 256. So it's about 4 megs a slice. So if we did 256 divided by 4, so we could have 64 depth slices of that, which would be massive. I don't even know if we can spare that kind of bandwidth, right? So we could certainly slice it up in a number of different ways and then store a bunch of lighting information into those textures. Once we store the lighting information into the textures, we can then downsample it to get various resolutions of that, right? And again, I don't know if this is a particularly good idea. I'm not trying to say one way or another whether it is or not, but it's certainly something we could try. The other thing we could try is say, well, what if we just stored an average direction and intensity? So we had only we had 3 textures, 1 for R, G, and B, and we had 4 elements per texture. We had intensity and direction. Right? I don't know which of these would be good, but you can see that there's like room to play around here. And so what I would propose we start with, just to get things rolling, and we'll tackle this a little bit more next week, is let's just try making one of these things with some flexibility. So we'll try to parameterize it on how many textures we want and how many elements per texture there are, so we can try either of these schemes or any other scheme we come up with, right? Try making a 3D texture, then rendering something into the 3D texture. Yeah, render something into 3D texture, and then sample from it, right? Now, one of the tricky things about 3D textures is I'm not really sure to what extent we have control in this version of the shading language over drawing into 3D textures in a deep sense. Like, I don't know if we have to render lots of slices for our light in order to properly fill the 3D texture. Could be that we do, could be that we don't. It could be that we can just fill it in a more creative way, but we might want to do that anyway just to avoid overfilling, so we might need to slice our lights up into several primitives or something like that. So I'm not sure. But yeah, what we would want to do here again is just figure out some way to get this process started by just creating those textures and drawing into them. One thing we could do is do this in screen space, well, we're going to do it in screen space regardless, with only one texture at first, only one texture, only one depth level at first. So instead of making a 3D texture, we make a 2D texture, and we just do the lighting in a plane first, and then we try to extend it out after that to a 3D, right? So there's a thought. I don't know. What I do know is that I can produce copious amounts of mucus, which is annoying. Anyway, so if we wanted to do something like that, then really what we're talking about is at startup here, we want to create some lighting information. So inside our OpenGL startup code, we're going to want to put something in here where, normally we don't allocate much in the way of textures at startup, but here we actually would be doing exactly that. So we'd have in here a texture handle that's like our light textures. And like I said, we don't know how many of those light textures they're going to be, but probably we're going to have to keep that to a relatively low number. So I'm just going to throw in an 8 right now, and so that we have the ability to do some of them, but they're going to be relatively modest. And here we'll also say light texture channel count, and that'll give us the parameterization we want. I could also do light texture count. So we know how many textures there are. We know how many channels there are per. And so in here, we could also probably in here now I think about it too is light texture width, height, and depth. Right. So what I would venture to guess is that these might want to be settings. So the texture count and the channel count are going to be things that probably get fixed to the algorithm that we choose, but the settings are probably going to control the width and height, because on lower end machines we would probably use worse sampling on the lighting, right? So much the same way that we can reduce the resolution of the game on worse machines, or increase it on higher end machines to give better or worse results, we could do the same sort of thing with the lighting. So at the moment, we'll just set it to something like this. But in the future, we might play with it more. So the other thing we can do here is say, what's the MIP level count? Well, that might actually be implied. Something like this, right? So let's go ahead and see what we would have to do to make this happen. So now that I think about it, this is probably not a gluent. This is probably a frame buffer. And the reason for that is we're going to render into these things in addition to reading from them. So they're not really just going to be a texture handle. They're going to be a texture handle plus a frame buffer handle. In the process of starting up OpenGL, we need to do some work here to make these things happen. And probably since they're going to be settings-based, what we want to do is actually do it up in the part where we have the settings change, right? Where is that? Oh, I'm having a spelling. There it is. Having a spelling problem today, having typing problems. So in here, what we want to do is when we create all of our other resources, like our depth peel buffers, we want to create in here our light texture buffers as well. And what we want to do is we want to make sure that we free these too, just to let the graphics card know that when we change settings, it can free up space to get rid of everything, basically, so it can free up space to create the new things. So we'll go through here. And just free these frame buffers. So they will go away. And then down here, when we actually need to compute the rest of our stuff, we're going to do the opposite process. So when we create our frame buffer here, and we may have to add some parameters to our create frame buffer call, but for now we won't. So you can kind of see here we know some of the stuff we're going to pass, but we're going to need to render depth there eventually, probably. So we're going to have to pass the current settings. Where is that at? We want from the settings, the light texture width, light texture height, and at the moment we don't have a place to pass the depth, so we're not going to, but that will create a frame buffer for our use. There is a problem with this, and the problem with this is that we don't want to for creating the frame buffer here, we're going to want to specify a specific type of storage that may not be the same storage as we use for like depth peels and stuff like that. So when it creates a frame buffer, you can see in here we've kind of got this filter type and slot and those sorts of things. Obviously we won't be wanting it multi-sampled, so that's fine. Filtered, we will want it filtered, so that's fine. We don't want depth, so that's fine, but we do want color, so that all works. But the OpenGL default frame buffer texture format part of this, that part kind of has to get fixed, because that actually will not work, right? So that has to get replaced with some ability, because what we don't want sRGB probably. I mean, maybe we do, maybe we don't, but we might want to store it as floating point. We don't know. We really don't know what we're going to do here. So that one's a little bit trickier, I think. All right. So just looking at that, the other thing we would need to do is for a frame buffer text image here, we would also need this guy to do 3D textures. So with width and height, it would also need a depth in here. And so we would need to be able to do 3D multisample or 2D, right? Which is one of the really annoying things about OpenGL is you have to call a different function if you want a different dimension texture. So it makes it harder to parameterize, but that's just the way it goes. Okay. But that's really all we're talking about for first steps here. Did I not? Didn't actually add these into the render settings. There we go. So we now have to compute sort of these values from it. Now, these two are going to be fixed based on the algorithm. So the light texture count, for example, let's say we were going to do one where we tracked, for example, the average direction and the average and the summed intensity or something like this, right? So all we're going to do is do 3 textures, 1 for R, G, and B, and 4 channels, right? For X, Y, Z direction and intensity. The MIP count is something that we want to know for other purposes, right? Because we're going to want to MIP map these textures down for various reasons that we'll see later. We're probably because we want to be able to sample from more blurred versions of them for a number of reasons, I suspect. And so that, at the moment, is something that we're going to have to compute from the information we're given in terms of the width and the height. So in order to figure out the MIP count, I guess one thing we could do here to make this a little more precise, since we need these to be power of 2, is we can also make it so that when we are talking about them, we could talk about them in terms of their power of 2, right? So rather than calling them, width and height or whatever, we'll actually just specify the power of 2 here. So in this case, we would say that this is, 981. So then if we want to know what the actual values of these are, we would then say the light texture width, the light texture height, light texture depth are all going to be equal to whatever the power of 2's are raised. And that's just a way of enforcing the fact that we are not going to let you specify arbitrary settings for these. You have to specify a power of 2 in all cases. So this is width power of 2, height power of 2, and depth power of 2. So then the MIP count is easier to determine. The MIP count is just going to be whatever the actual texture width is. The power of 2. For the width, if the width is the highest thing, if it's not, then it's just whatever. We can just keep going here. Oops. Whichever one of these is highest is the number of MIPS we would have if we went all the way down to a single pixel, or single texel, I should say. So that's the MIP count, right? That's how many lower resolution versions there would be of this thing. So then when we create one, it would look like this. And again, we're going to want to adjust how we're doing this, but for now, we'll just say okay, so we've got one. It's fine. So that's how we would create our light textures, and we would create one for R, for G, for B. So there's going to be 3 of them. And again, their channels would be X, Y, Z intensity. So like direction X, direction Y, direction Z intensity. I guess... I mean, if you think about it, I guess really we don't need to specify 3 there, because if we just sum up the R, G, and B values in their entirety, you could just go with 3 channels. So you could use like 3 16-bit channels rather than 4 8-bit channels, but I think we probably want 4 8-bit channels, would be my guess. It's hard to say. So what I'm thinking about here, just to be a little bit more explicit about it, so one thing you could do is, let's say you had 3 floats. You could just take the direction to the light and its intensity, and scale it. So we have direction and we have intensity. We would just do the direction times the intensity is a vector that's as long as the intensity is. We would just sum those together. So it would just be the sum of all the intensities multiplied by their directions. And that would just give us one value that's like, here's the direction of the red light and its intensity roughly, right? Now the problem with doing something like that is it means that opposite directionalities cancel. And maybe we want that or maybe we don't. I have no idea. But for example, let's say we have a strong red light coming in this direction and a strong red light coming in this direction. They would cancel each other out. That doesn't seem like a very good thing to me, right? So what I assume we would want to do instead is, while we might want to do this in terms of making it so that brighter lights dominate the directional component, we probably want to sum the intensity, because otherwise we'll get all these weird anomalies. So that's why I'm thinking what we want is 3 directional ones and 1 intensity one, and the intensity one just gets summed, whereas the directional ones have that ability to cross-cancel because there's negatives in there, right? There's no negatives in here. These are all positives, but this one has positives and negatives. So yeah, that seems reasonable. The only issue there is this is going to require more than 8 bits probably, if we're honest. At least if we do want there to be a strengthness to it. So that's hard to say. Fortunately, that's an easy thing to determine. What we can do is use floating point textures to start with, so that we know that we have pretty much infinite flex room. And then what we can do is scale it down to 16, see if we can make it work, scale it down to 8, see if we can make it work, right? So we can basically start with a very bloated representation that we know won't have problems with range. And we just successively get simpler as we move down the line. That seems like a pretty good strategy to me. So yeah. All right. So here we create the frame buffer. What I want to do in this case is make that create frame buffer call. I would like that to have a flag in it. Let's see if what we've got here, filter type format, yeah. So what I would like to do here is I'd like to make a B32X that says, is float or something. And if we use isFloat, then when we determine what the type is of the texture, we're going to force it to be a floating point version, right? So what I want to do there is this default frame buffer texture format thing probably has to go. What we probably want is are frame buffer textures sRGB or not, if that makes sense. And so we probably have to expand this a little bit. And then OpenGL depth component type, you can see why this is a little bit nasty, right? Because this, again, also kind of wants to know this information. Did we test to see whether we can use a non-floating point depth buffer, by the way? I don't remember if we did that. Let's take a look at that. So there's with our floating point depth buffer. I could also turn off the lighting for that. So looking at this, probably want to keep some of that there. Okay. So looking at this here, you can see where we're at in terms of render quality with the floating point depth buffer. And I had not really tried playing to see whether we need the 32F or not. So we could try depth component 24 and see how it is. Unfortunately, with the lighting on directional like that, it's pretty tough to tell. But you don't see obvious artifacts in normal play. So it does seem like we could probably get away without floating point depth buffer. Now that doesn't necessarily mean we want to. So yeah, like we have some options there, and yeah, it looks like that's probably something we could parameterize in the future. I don't know that there's much reason not to use the floating point version, but we might save some bandwidth or get a little bit of a performance win on some situations by not requiring such a heavyweight Z buffer, right? So anyway, we're pretty good on here, and we're actually creating those light textures now, actually, even though we don't use them for anything. So now what we really want to do is we want to be able to sample from these lighting textures when we're actually doing our drawing, right? So what we want to do here is inside of our lighting, we've got a ton of code here that we were using for our lighting. So here's all of our lighting code, right, that we're doing. And we don't really want to be doing that stuff anymore. The end is correct, right? We do want the total light value to come out. But we're going to want that to be an actual vector for, so we have an RGB, an RG and B light there. So we actually do kind of want to play with this last part a little bit, but we don't want the rest of this involved at the moment, probably. Although I guess now I think about it, I guess we just can kind of use it. Because we will, while we won't necessarily have this part here, right? So this part kind of goes away. Well, that part kind of goes away, so we just have cosine angle equals dot, like to light world end there. The to light part is going to be the thing that we read out of the texture, right? So we're going to read that to light direction out of the texture directly and use that. Similarly, the lighting distance part is exactly the same. That part's going to get read out as well. So I'm just kind of organize this up here. So what we end up with, right, is we've got a diffuse coefficient for the surface, which is something we may actually put into the vertex stream at some point. We compute the diffuse light by just sort of multiplying in by that lighting value, And what we really want to do here, I think, is we want to start treating these as vector equations so that we can do an R, a G, and a B together. So I think what we want here is we want this to be a V3 where we'd have the diffuse coefficient times the cosine angle, which will be different per channel. So that'll be a vector 3, right? This will actually be a vector 3. And then we've got that light strength, which will also be a vector 3. Same would be true here. We'd have the specular coefficient, which is still a floating point value. That's just a property of the surface. We'd have the cosine reflected angle. And again, that's going to be exactly the same thing here. It's just going to turn into a vector 3. And then we would have the light strength, again, is also a vector 3, right? Then when we compute the total light, that will produce another vector 3, again, turning this into an RGB separated equation. So I'll make that work with the current way we do lighting, just because that way we can sort of just test to make sure it's working at all. So the way that this would work is the light distance computation now is something that is going to happen per channel. So we kind of have to take this and blow it out. The same is true for the dot product. There's really 3 dot products now. That makes sense? So it looks more like this. And again, same here, where we get of these. Oh, right, 4-coder will fight me on that. Okay. Yeah, so there's... So really what we're looking at now, right, is we're just trying to expand this out to handle the fact that soon we will have different light strength and different light directions per color channel. So the 2 light vector will be 2 light R, 2 light G, 2 light B, and the light strength will be light strength R, light strength G, light strength B. Then the rest of these equations are still fine. Right? There's nothing else that we need to do in particular. Oops, this one's got to do the same thing. The rest of the equations just flow properly. They're just done per channel now instead of for once for the entire light. Probably, since I can't quite see the parsing of these things, I just am missing parentheses or something in here. Yep. And so this is the exact same thing we were doing before, right? And we don't see any change because we're not doing a different R, a G, or a B, right? But what we could do if we wanted to is, since the light strength is specified here, what we could do is actually do a light strength R, or guess now I think about it, I could just do it here. So in this case, right, we've got a light strength R, G, and B. Light strength R, G, light strength B. So I could make my light be a color. It could be sort of, orangish or whatever. And then when, it lights the surface, it's kind of tinting it, right? And similarly, I could knock out the blue entirely, and then there's no more blue light. So now everything is like a greenish yellow, a yellowish tinge to it, right? We could make it red only. Oops. And now it's kind of like Handmade Hero Photographer Darkroom Edition. And so, that's just prepping for flowing these things in from a texture. So then if we wanted to start flowing them in from a texture, then what we would do, right, is instead of passing down a light P here, where there's a specific value that's set as a uniform, we would actually, okay, I'm out of time, so we'll do that next week. We would just pass in here textures to sample from and sample out the light direction and light intensity for each channel from the corresponding 3 textures. And that's all we'd be doing. So pretty straightforward, if that makes sense. Okay, we can go ahead and go to the Q&A. I don't want to start doing that because we won't have a chance to finish doing that. Oops, that didn't work. Whoa, Insobot? 12 minutes into the main stream. Why does Insobot think that? Is the time set wrong on the schedule? No, it's set right. What happened to Insobot? Miblo, on a scale of 0 to 15, how disappointed are you that Visual Studio continued working as normal today? I'm not disappointed that it continued. I'm actually relatively happy it continued working as normal today. Just because I don't like having to change development environments in the middle of a project, right? I like being able to just stick with one reliable. That's why we also don't update Visual Studio. Like we could go switch to Visual Studio 2017, but I don't want to do that because it just brings a bunch of hassle. Like there's different things, it has different errors, there'll be different bugs, right? So mostly I started on Windows, I want to finish the development of Handmade Hero on Windows, and then never use Windows again, right? But I don't really like switching per, I don't like changing horses midstream, to quote Wag the Dog. Disuse, don't you find this lighting way too advanced for a 2.5D game? I don't really think there's any such thing as too advanced lighting, for lack of a better statement, if that makes sense. Lighting makes games look awesome. You really can't have too much lighting in a game. You can have bad lighting in a game, or lighting that isn't appropriate, sure. But having a good lighting scheme makes games look really good. And I think when you see 2.5D games that have good lighting, you notice too, like they look really nice. So no, I don't really think so. So yeah. Uplink coder. Can I stream C to D conversion of Handmade Hero without infringing on the copyright? Yeah, just email me and I will give you permission to do what you need to do. Basically, like, I just try to keep the source code is private to people who haven't licensed. So as long as you keep the D source code private, you know, and you could put it on the Handmade Hero GitHub, for example, if you wanted to, which is private, until the code is released into the public domain. Then that's fine. But yeah, since obviously the streams are free, anyone who wants to can watch the Handmade Hero streams for free. So watching D streams of the same thing seems fine to me. How excited are you for Pear's project? I haven't seen Pear's project. Is it on Handmade Network? What's Pear's project? I'm assuming you're talking about pair, this pair. What is Pear's project? Is there a link? Shock93. No, he is making an entire computer from scratch using FPGAs and hardware. That sounds cool. I wonder if it could run Handmade Hero. There is another person who's doing that as well. Risky 5 is doing that, I think. Will John ever do Handmade Compiler? I don't know. He threatened to do it, but he hasn't done it yet. Maybe he will want to do that sometime soon. I don't know. No, so Miblo, I'm not talking about Miyotatsu. I'm talking about Risky Five's project. He did a FPGA. I don't know how to search for this, but he did an FPGA that plays games, and he asked about making one that would run Handmade Hero. It's not RISC-V. The person's handle is Risky5, but it's not about the RISC-V. Whereas, yes, Miyotatsu is doing a RISC-V handmade toolchain thing, but that's different. I know this gets confusing. I get confused. I can't remember who is doing which sometimes for the handle, especially because I may know someone's actual name, but I don't know their handle. All right, looks like we don't have any Q colons here, so I can wrap it up. Oh. Cuber Caleb, short of the fact that most gamers use Windows, is there any reason to do most of the development on Windows? Yeah, it's more stable for debugging by far. My experience with trying to debug GPU stuff on Linux has not been good. And the debuggers on Linux I also find to be not good. So editing on Linux is fine. Compiling on Linux is fine. Like Clang is good. It's, you know, if anything at this point, probably better than Visual Studio's compiler, like, right? But trying to like run, debug, and analyze graphics intensive applications on Linux is not good in my experience. So part of that is probably because I'm probably a little more biased against it than I should be. Like I can say definitively that the debuggers suck. Like Linux does not have any debuggers that are have good human factors, in my opinion. Graphics debugging is probably, I'm being a little unfair, and the reason for that is that when I've done, when I did graphics work on Linux, I was using a laptop, and the difference between Windows and Linux in terms of handling laptop graphics is like, you know, an unfathomably huge gulf. That's not true for desktops. Desktops, Linux is much more comfortable when it just has one graphics card to deal with. So it's probably much better in that regard. So that part probably gets better. Just, you know, get a graphics card that's a well-tested Linux graphics card, whichever one that should be. And, you know, whether it's NVIDIA or AMD these days, I don't know who has better support. And that part probably takes care of itself a lot more. On what I found was that for trying to use a laptop with it, its support for, you know, Optimus, you know, discrete switchable graphics is just really bad. So. Raycaster, do you have any anecdotes of horrible debugging experiences using Linux debuggers? Oh, sure. So my experience using Linux debuggers, you don't even have to get complicated. I found that in a full debug build, so no optimizations enabled, I found that most Linux debuggers, if not all except for direct use of GDB, command line GDB, none of them could even display the elements of a lot of my structures. A lot of them couldn't display local variables. And this would tend to be fairly random. So it would just be like, yep, that function, we don't know where the local variables are, sorry. Or that structure, we can't, I don't know, I'm sorry. And this happens all the time. So I would just generally be in cases where, you know, it just doesn't work. When it does work, it's incredibly slow. Single stepping took an eternity on a very fast laptop, right? I could watch the time it took to like get from line to line, you know? And it's just nuts, right? So I found the debugging experience on Linux is just horrible. There's no reason that I know of that it has to be horrible. Like I don't think Linux as an operating system has some core problem, you know, at its root that means debugging can't work. But whatever the reason is, whether it's the fact that everything's like a tower of cards built on GDB or something, or whether it's the dwarf model is bad or something, I don't know, I haven't studied it. I don't know what the problem is, but there are problems. Have you considered Visual Studio Code over Visual Studio? Still Microsoft, but much more lightweight, and you get the Visual Studio debugger. Are you talking about on Windows or on Linux? Raycaster asks, have you tried visual debugging using Qt Creator? It does not seem to have the issues you described, at least not for honest parts. That actually was specifically the debugger I would say had all of those problems. Because I did use that one. It was the least bad. And it has all of those problems that I just described. D. Mitsuki, on Windows, on Linux, you don't get the VC++ debugger. On Windows, no, I haven't. I'm happy to try it, though. Is there a 64-bit version? Probably not. There isn't a 64-bit version of Visual Studio, so... I don't even want to know what that agreement said. I like it how, like, just a thing that's just an editor debugger has to install, like, 8 billion files. It's like, why isn't it just an executable or, like, 2 DLLs or something? I have no idea. Gotta have more JSON, I guess. So let's see. Here it is. Oh, I don't know what happened there. So here it is. If I want to debug something, can I debug an executable somehow? Debug. Add configuration. Open a folder. Okay. Let's open a folder. W. Handmade. MISC. Build. Can I debug now? Debug. Debug. Open configurations. I really don't want you to use Git for anything. All right. Install. Is it installed? All right, how do I debug? Debug. Debug the program. Add configuration. C++. I want... Okay. I want, this is what I want. Debug the program. Please. Start debugging. I want C++. That's the environment. Okay. I would like to debug now, please. Debug my program. Please debug it. Will you debug the program now? Debug the program. So how do you debug the program? Reload. Okay. I will reload. I have, oh God. Okay. I have reloaded. And now I need to reload again? Okay. Here we are. I want to start debugging with Windows C++. I want to do something here. Enter a program name. Here is the program name. It's W build Win32 handmade.exe, right? Is this the working directory? So the working directory is W build. No, it's not. The working directory is W handmade data. Right? Add configuration. Oh, fuck. Okay. Oh, wait, I'm not supposed to swear on the stream. All right. I don't know what to do now. So, okay. I have put that in there. There is the configuration. And everyone's happy, right? There we go. All right. So we got it launching. So I'm assuming, can I step into it now? Step in. Step into the step. Okay, that just changes it to full screen. How do we step into the first line of the program? Right? Well, let's set a breakpoint then, I guess. Can I set a breakpoint? New breakpoint. Just a function breakpoint. Set breakpoint. How do you set a breakpoint? Debug. New breakpoint. Function breakpoint. Okay, so that didn't work at all. Debug, new breakpoint, conditional breakpoint. That didn't work either. All right, we're on a roll here. We're really getting some debugging going. Can't seem to set any breakpoints. So that's fine. I guess I'll just hit start debugging, and then I'll hit break. So break. Nope, that wasn't break. That was stop. Start debugging. That break? Okay. So we broke. There we go. Here's our main thread. And it has no idea where the source code is. All right. How would I tell it where the source code is? Debug. Load symbols. Anyone? So, open folder, select source folder. Okay, so oops. Handmade code select folder. What just happened? Okay, so that... No, so I guess my short answer is, unless I'm really missing something, no, that's awful so far. Did that leave crap in my directory, in my build directory as well? Or did it was it mercifully? Yes. Awesome. So it also crapped out whatever this is, which is that launch program we did. I would have to play with it more to see whether I cared, but chances are no, that I have a lot of doubts that that is going to be a particularly good way to debug stuff. But yeah, I mean, I also don't know that this is necessarily designed for something that I'm going to want to do. Either, right? I mean, it's designed as an IDE, and I just want it to run the debugger. So it's, by definition, probably going to be something that doesn't particularly work. But okay, Desuused, if you think I'm being dumb, walk me through it. Allow me to debug my program at source level with this tool. Hit me. I'll follow the steps that you type in. I mean, obviously, I'll launch the program for you. Well, I don't know where it went, but hold on a second. We'll get it back. There it is. All right, so we're launched. We don't need Git for anything at the moment. So hit me. What's step one? Okay, open folder code. That is, wait, so you're saying that's what we have open right now, right? Add configuration for C++. So that was this, right? Windows, I'm assuming. And we got to do this again. So it's w build win32 handmade.exe w handmade data, right? And I'm assuming I have to save this, but it might save it automatically, but I'll save it myself just in case. All right, so now add breakpoint wherever you want, start debugging. Okay. So I just wanted to step in to the first line of the program. So here is the first line of the program. Debug, toggle breakpoint, run. There we go. So I guess the answer is it can't load source out of a PDB. So what do you do if you have multiple source folders? Do you add source folders somehow? Like, let's say there was another source folder in a different directory. How would I specify this? Can I not do that? You can add more, include directories. So how do you have to do that manually? Like, would I do that in a project file somewhere? All right. Well, anyway, so let's see, now that we actually can look at something. Let's see how the single stepping speed is. Okay, dude. Seriously, though, I really don't think I'm being dumb here. Are you looking at this? Did you see how long it took to step over? That was nuts how long it took to step over desired schedule ms equals 1. Look at how long it took to step over window class equals nothing. Those were a little better. But man, that speed is awful. That one's fine because that's an OpenGL. That might actually take some time. But that should be instantaneous. And those two should have been roughly instantaneous, and one was way longer than the other. Look at how long it took to step over that. I mean, that feels exactly like a Linux debugger to me, only Linux debuggers actually weren't that slow. They were faster than that. That was setting monitor refresh hertz to 60. That's how long it took to step over. I'm assuming this is because this window is really non-performant. Like if I close that, all of a sudden it's totally fat, right? So this is really bad for some reason. They must have a really slow version of that. So if maybe you just leave the watch window as the only thing open, right? Now the speed is actually usable. Oops. Now the speed is actually usable. So maybe if you just use a watch, let's see how this is. So there I have one watch open. That seems fine, right? So it seems like maybe if you just can't, like, don't look at locals or whatever. I could live with that. I see they inherited some of the badnesses of Visual Studio's debugger as well, like, for example, not being able to look at a variable after the instruction of a loop when you hit the closing brace. I hate that, but Visual Studio's debugger does it too now. Didn't used to, but does now. So that, I could deal with that, assuming that it doesn't get appreciably worse. Okay, I don't know what just... Now it's extremely slow for some reason, but I have no idea why. All right, where is the cursor? Does anyone know even where the cursor is? What? Wait, what? We're down here now? Oh, because I must have... Okay, all right. Well, let's see. Can we step through the assembly? How do I see the assembly code? Disused, how do I step through the assembly code? Help Togger developer tools. All right, that's not useful. Can I step through the assembly? It can't do, oh, okay. So you can't even see a disassembly, even of stuff it can step through? So why are we even talking about this then? I mean, we need to be able to step into assembly, right? I mean, that's a... Yeah, so, all right. I mean, that if someone had told me that at the beginning, we wouldn't have bothered trying it. I assumed that since it used the visual... oh, but D. Mitsuki says you can step through the assembly? How do you step into the assembly? You have to debug with minus exec disassembly. What is minus exec disassembly? Where do you set those parameters? Are they in the launch.json file, or are they a parameter to the actual program? It's in args. So it's in here? Can I just put it in, like, literally in here? Or is it... I don't know what the format is for these, obviously. But that's the args to my program. So, I mean, I wouldn't pass that to my program, right? Doesn't really make sense. Oh, okay, in the debug console. All right. So let's say I want to view this assembly here. So you're saying I could do it here. Oops. Where would I specify? Because this wants an actual command, right? Is it in here? Yeah, I don't... It doesn't know that as an actual thing to type in here. Maybe you type debug exec. Debugger. I don't know, we need some kind of a tutorial here to say just disassembly is the command. Okay. Disassembly. I mean, I can't say it's looking encouraging at the moment. I mean, there should just be a thing, like, show me the disassembly. Like, I don't understand why I would have to have some kind of fancy mumbo jumbo. Control-Shift-P. Disassembly. Yeah. So I guess I should ask the other question is, was that to imply that there's also no memory window? Yeah, seriously, man, I don't know about this. Like, this seems like it really does not have what I would want, but I mean, you know, maybe if you're very familiar with it, maybe you know the secret way to get some of this stuff. But, you know, I obviously want the ability to just, like, see the disassembly at any time, and I need to be able to see the memory, like, view memory at any time. What's the reason behind checking out this atrocity of a program? Someone asked on the stream, so I checked it out. I would say, like, it looks, like I said originally, it really looks unpromising. I would not suspect it would work very well based on what I saw there, but, you know, maybe if you learn all the... I mean, to be fair, you have to learn how to use Visual Studio as well, right? And I just happen to know how to use it. So it might be that there's some kind of specialness there, but I don't know. So I wouldn't say that looks very promising, no. As for Liza, I would love it if that was working now. Or also, there's two Handmade debugger projects now. There's LYSA and also the, what was it, something DB. Remedy BG. So there's this one too. So there's actually two projects. Debugger projects going. Here's one, here's the other, and they both just made Patreons recently. Unfortunately, as far as I know, neither of them are actually available yet. Hopefully one of them will work. I don't know. Frosty Ninja, how do you feel after today's stream? We nearly switched to Linux, and now you're looking for answers regarding to web editor on Stack Overflow. Yeah, it's not great. This is why development is just not very fun anymore, and I try to isolate myself from the world of development at large. It's just not a pleasant place. Raycaster, are you still tempted at moving the project to Linux? I would not like to move till we're done. But like I said, I will probably move Molly Rocket over to Linux next project, because Windows is not really viable anymore, in my opinion, as a thing to like base your company on. It's way too unpredictable, and it has to be connected to the internet, and it's bad, right? So it's not really something I would consider for the next run. So I'll be moving to Linux in the near future for my own stuff. Handmade Hero, I'd like to just finish on what we started. The same reason I don't move to Linux in the middle of our current project at Molly Rocket, right? Because it just it throws a lot. It's a big disruption. So I'd like to be able to finish, and then do a switch in between projects. That's kind of better, I think. So yeah. Oh yeah, don't forget to delete the VS Code folder. Thank you. I love that it just drops. You don't even ask it to do that, but it like creates its own like yeah, it creates its own stuff everywhere. dir/s VS Code. Okay, I think we've got it. Thank you for that reminder, Asaf. All right, I'm gonna wrap it up. Thank you, everyone, for joining me for an episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the series at home, you can always pre-order the game, and it comes with the source code. Maybe you should go run it on Linux. In fact, as you saw today, you can't really trust Microsoft tools to run day to day. They may just decide that suddenly they need to talk about a license. Yeah, so if you would like to ask questions, we have a forum you can go to. We also have a Patreon page from us, part of the video series. We have a schedule bot you can go to if you want to know when we're going to be live, and an episode guide. With past episodes on, if you want to catch up on the series, we'll be back next week to work on the lighting, which we now created some textures for, and we will have to fill those textures up with something. That's about it for this week. Until next week, have fun programming, and I'll see you on the internet. Take it easy, everybody.